All right, all is set up. So let's get started. The first thing I would like to do is go back to the slides that we went over at the end of the last session. I went over them like a freight train. So most of it was okay to go over real quick to let you read it after the class, etc. That I just want to make sure that I comment on because this is important, okay? So this is right after we introduce substring, okay? The next method that I wanted to draw your attention to in terms of strings library in Java are the index of family of method, okay? So there are many variants, index of with one character that is of data type char, or index of with a char and then an int value that tells you where to start the search, index of with a string and an index value that tells you where to start the search. And once you understand index of, so index of is going to allow you to go look into a string, starting at the beginning of the string, finding the first occurrence of that character, and returning the index where that character occurs. Okay, easy stuff. So if I don't want to start at the very beginning of the string, index 0, then I can specify here another index, index 3, and now the search will start at index 3, and the first character that matches this character, the method is going to return and tell me where it's located. But it always goes left to right, from the beginning of the string to the end of the string, starting at 0 or wherever you specified, okay? And then same thing here, but this time I'm not looking for one character, I'm looking for a substring. So if you say index of hello and you have a string that says, I'm going to start the lecture by telling you all hello, well, it's going to browse from index 0 until it finds the H, then verify that there is an E after, a L, a L, a O, and if that's the case, it returns the index of the first letter, the H. So we can really easily find substrings, actually, inside of strings. And then the next logical thing would be, well, if I can locate, where a specific character is at, if I can locate where a specific substring is at, then maybe I can combine this together with the substring method, and that would allow me to find something in a string, make a copy of it, extract it, and process it for whatever my goal is in my program. Once you have a decent idea of index of, the 4 methods at the bottom of the slide are exactly the same thing, except they're called last index of, meaning that instead of starting the search at the beginning of the string, going towards the end, they start at the last index of the string, going toward the index 0, okay? So if you use last index of and you don't specify a from index, that's the first variant here, it's going to look for this character starting at the end up to index 0. If you specify an index, it's going to start at that index and then go toward the beginning. So one way or the other, you can search for single character occurrences, or substring occurrences. So here's just a quick example to illustrate it. So we have a string that says Kim space Jones, and we want to extract first name, last name from that string. So first step, let's say that this string is stored in an object that is referred to by a variable s. S.index of find me the space. So I didn't specify a starting index, so I start at index 0. I find the space character here at index 3. The value 3 is returned. K is therefore 3. And now that I know where the space is located between the first name and last name, I'm able to do string first name equal s.substring 0k. So remember, the final index is never included. So from 0, that's the k for Kim, up to the value of the variable k, which is 3 not included. So I just substringed out of this Kim. And then last name equal s.substream, k plus 1. So I want to start here. If you do k, you get the space. So k plus 1, and I use a version of substring that takes only one parameter because I want everything from k plus 1, 4, to the end of the string. Okay, so very easy in Java to manipulate strings. There are languages that make it even easier, but this is already pretty good. So we can extract first name, last name like that. The only problem is, well, what do I do if I have several spaces? And that's kind of what the exercise at the end of the slide deck was there to show you. Okay, get you some practice with substring, get you some practice with trim, get you some practice with index of, and put it all together in a problem that is a little less trivial than this kind of example, where we want to isolate words in a text, but we don't know how many spaces are in between the words. Okay, unlike here where we know exactly the format of the stuff. So we are going to go to the exercise, okay? Real quick, I'm going to just scroll through the rest of the slides that we didn't cover at the end of last lecture, but you're going to see that this is stuff we already talked about, okay? So this is the time where we officially introduce in the textbook the next method from the scanner class. The next method by itself means I want to read one word. So if you do something like, create a scanner, tells the user, enter 3 words, and then you read 3 times input.next, 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 input being the name of the scanner, okay? So what you do each time, you look at what the user typed, and you're going to return a string that corresponds to everything the user typed until the first separator. So separator for scanner, that means a space, a tabulation, one of those characters, okay? And then you call it again. What happens? Well, whatever the user typed initially is not lost. Like many programming languages, Java is using buffered input-output, meaning that when I type, hello there, people, enter, right? The whole string of what I type is stored somewhere. It's called a buffer. And then when I call input.next actually goes and checks that buffer, that part of memory. And it says, okay, what was typed recently? Hello and a space, okay, I stop here. But the rest that I type is still there in the buffer. So if you want to look at it that way, input.next is going to just extract from the buffer the first word that was typed. And then when I call it again, what happens? Well, it's going to extract from the buffer for whatever is left in the buffer. So space, there, people, we're going to extract the next word. And then the last time I call it, there's going to be something left. It's going to extract the last word. And then there's nothing left. I hit enter and that was it, right? So if I was calling input.next a 4th time, then it would hang. The program would stop and it would look like it's doing nothing because it's waiting for me to type more data. Okay, so that's how the input, sorry, not the input, the next int, next double, next line that we're going to review on the next slide, all of those methods of the class scanner, I kind of simplified it a little bit when I first introduced them. I told you they are going to wait for you to type something on the keyboard. Well, it's true, but like all best lies, I mean, it's partially true. So yeah, it's partially true. Okay, they are waiting for something to be typed as a keyboard, but there is one more step to the process. It's buffered. So you type, hit enter, it goes into a buffer, and then the scanner reads from that buffer. That's it. And then we can display S1, S2, S3. We display each word. How to read an entire line? We already did that. Okay, so I don't have much to add on that one. It's just the next line method. And when you do next line, now you can understand it better, right? When you call next line, not only the scanner looks at the buffer, but it's going to take out of the buffer every character that was typed until and including the enter character, okay, that represents you hitting the enter key. And it's going to take all that and process it, return it to you so that you can play with it. So every time you try to implement some sort of command line, it doesn't have to be a command line interface. So you're not necessarily re-implementing a shell, but every time you are like consuming an entire line from a text file, for example, one line at a time, and then you try to figure out what information is inside this line, you are doing some form of parsing, okay? And most of the time we use this, whatever scanner name you have here, dot next line, to get that chunk of data without the scanner trying to play with it first and chunk it up in pieces or something like that. So that's pretty weird. The last one that was missing was how to read a single character from the console. And this is not what you're going to be able to do like the next Tetris, okay? This thing is actually reading an entire buffer, so input.nextLine, and then it's using char at that we talked about last time to look at, oh, what was the first character, and I'm going to ignore everything else. So the reason I say this is not how you're going to implement the next Tetris is if you think of reading a character, being able to detect whether the user presses the right arrow, the left arrow to move, something on the screen or something like that. That's not it at all, okay? This is just read an entire buffer. So the user has to type one character and then type enter. And then we are able to read that entire buffer. And then we're able to look at the first character. So that's standard Java. As far as I know it, there's no better way to do it. Maybe I'm wrong, okay? But that's the standard JDK with Java. If you ever want to do something where you're using WASD to move something on the screen, then you will use something completely different, okay? You would use probably I don't know if it's a third party or a JDK library that does that somewhere, but you would use something that's going to listen to keystroke events and things of that nature, okay? But you would not use actually next line, etc. So there's really no way to read a character on the fly like that with the scanner. Next topic, printf. So moderate importance, okay? I mentioned it, I'm going to mention it and spend maybe 2 minutes on the side, I don't know, something like that, just because of COP2515. When you get to COP2515, the C language is using printf all the time. We have been getting along with using print, system.out.print, system.out.println, and it was fine. And honestly, we can continue like that. And when you guys take the final exam, you can definitely read your output stuff on the screen using print and println. No problem there, okay? This is just extra so that you know what's coming up next, sort of. So printf is another one of those methods that display something on the screen. So system.out.printf, okay, you see it in action here. The syntax is a little bit weird the first time you see it, that's all. When you do a printf, you could do a printf between parentheses of hello world, and that would do exactly what print is doing, okay? Print hello world, printf hello world, same thing. But printf allows you to separate with commas here and specify multiple parameters. So when you have multiple parameters to printf, it's more than just a print, okay? What it does is it's going to look always at the first parameter you specify here. It's going to always be a string, and printf is going to interpret it as a formatting string. What does that mean, a formatting string? That's going to give you an idea of what you want to display and where you want to insert specific values inside that display. So those of you who did Python, maybe you heard about string interpolation, something like that. It's kind of the same idea, okay? But it's Java source. So how does that work? Well, you have a string here, and it tells me what I want to display. I want to display count is, and there is something here, %d. So I don't want to display %d. It's another one of those characters that has a special meaning for printf, okay? It doesn't have a special meaning for print or println. I can display %d all day long. But when you use printf, if you have a %d somewhere in that formatting string, it's going to have a special meaning. Coming back to that in 1 second. And then I want to display a space, and the amount is, and a space, and %f, another one of those codes. Everything that starts with % is actually a placeholder, okay? It's like saying, right here, I'm going to insert a value that is a int value, okay? That makes sense, D for int. And here, I'm going to insert a value that is a floating point value, actually a double value. So F for double. So besides the fact that the letters here, they stand for decimal and float, and they are a little misleading depending on how you look at them, okay? The idea is that for every type of data you want to insert here, whether it's an int, a long, a double, a float, a char, a boolean, a string even, you are going to have a special 1-letter code. And don't learn those by hand, okay? Just bookmark the page of the textbook that has the same table I'm going to show you in the next slide, and you're good, okay? But that's what you need to know, % and a 1-letter code that tells you what kind of data you want to insert. And then how do I specify the value that I want to be inserted in that location in the text that I'm going to display? Comma count. The first argument after is going to be used by printf to insert a value here that I read from this expression. So this could be a variable, this could be a literal, this could be a whole expression, a call to a method that returns something. You know the deal, right? When I say an expression, it's a lot of stuff that could just yield a value. And same thing here. The amount is right there. Okay. So the amount is a double. So double matches person F. Um, the count is an int, it matches person D. What I'm trying to remember right now is I think that in the latest release of Java, the compiler will tell you something if you use, for example, person D, but you put a double expression there, matching, the person D. The compiler will double check that, but the compiler should be able to warn you that something is wrong, okay? But that's either the latest version of Java or another language there are from Java that I'm confusing it with. But the bottom line is when you go to 3515, you are going to use printf in C. But guess what? If you don't match the data type to the format specifier that you used here, person D, so you say the count is person D and then you put amount there, which is a double, then the compiler is not going to catch that for you. And it's not going to necessarily even crash. It's going to display some weird stuff, okay? So that's the main difference between Java and C. Java, no matter what you type, is doing its best to double check. Java doesn't trust you. And at least in my case, Java is right most of the time. But C trusts you blindly. So if you say, I want to display count is person D, and you pass a variable amount, and that amount is a double, but you use person D, which should be for int, C is going to say, oh yeah, you want me to read that part of memory and interpret it like if it's an int. I Captain, okay? And it's going to display something weird. That's a general philosophy. That's why I've been kind of preparing you from the get-go. You are going to learn programming with Java, okay? We could have picked Python or whatever, it doesn't matter. You learn programming with a language that actually tries to warn you of mistakes for the first class, the second class, and then the third class that you do programming, you kind of up the ante a little bit. You're going to put a little bit more pressure on you. You're going to use a language that is thinking, well, you guys know already how to program. So if you tell me to jump, I jump. But then you have to be super careful. By then, you have to develop that discipline of, doubting yourself, double checking yourself, and stuff like that. All right. So here's an example of what you can do with printf. So we use the \t character sometimes to make some horizontal spacing. Well, it doesn't always work. So I'm not going to show you an example because that's not worth the time. But if you are curious, hang around 5 minutes after the class, I'll show you. But yeah, the \t is not always perfect to align data in columns. So this is pretty much one time where we are going to want to use printf. If I want to display some data like this, either in a text file or on the console or something like that, where I want each column to be aligned at certain position like that, and I want the numbers to not display 16 significant digits, but truncate, after 4 significant digits. When I want to do stuff like that, then I use the syntax. And the exact syntax, it does not matter, okay? So I'm not going to teach you how to left center, a number with 2 significant digits in a window of 10 characters, because that's exactly what we're talking about here. When I do %d, between the percent and the letter, like here and here, between the percent and the letter that correspond to the data type you want to insert, you can put a lot of stuff. Like for example, here, percent minus 10d. Minus 10d means you are going to display on a window of 10 character, either in the file or in the console. So that means that every time I display this, it's going to be in a loop somewhere, whatever. Every time I display this, no matter how many character it takes, I'm going to pad with spaces at the front or the bottom. So if I do 10, 10, 10, 10, 10, I define the size of my columns. That's it. The minus means left centered. Like when you play around, when you mess around with Excel, everything that you can do on a cell, like the numbers are left centered, right centered, centered in the middle, more or less precision, etc. That kind of formatting of the cell, this is exactly what we're talking about here. So there are options also for doing, for example, minus 10.4f, which means, 10 character wide, minus, I'm going to left center, and then dot 4 means, hey, it's going to be a floating point number, only displays the first 4 digits after the decimal dot. But it doesn't change the number. The number that's stored in memory, so holy shit, okay, hold on. 1, 2, 3. So the third one is, the second one is a float, so that's not too bad. So the number that is stored inside of here doesn't change. But when printf displays it, it only displays the first four digits after the dot, okay? So it's not exactly the same as truncating and stuff like that we've seen before. So it's all pure formatting. That kind of stuff, you need to know that it exists. Hence the last actually 5 minutes or something, okay? But when you need the detail, you refer to the doc. I'm not going to ask you to mess around with tables like that and do like formatting of the screen in the final exam or something like that. But the quizzes, yeah, the quiz after game, they might ask you, hey, how is that going to format the output? How would I format the output if I wanted to do this? But this is why you have open book. All right, and that's it for the slides that I didn't have time to finish last time, except for the two exercises. So one exercise was converting an hexadecimal digit into a decimal value. So you have the solution, I'll let you look at it. The second exercise was write a program where you can type a message. The program is going to read that message, and then the program is going to have a loop that's going to tell me, hey, the first word that you typed is hi. And we're going to obtain the first word by doing a substring operation on the string that was typed. And then the second word is there. The third word is people. And I gave you that weird stuff. I gave you that so-called parson puzzle where pretty much the solution is there. So now this is for the potentially embarrassing moment. How many of you solved this? That's a spirit. How many of you tried it? Thank you so much. Okay, you guys can like send him money or get some cake or something because he saves the day for me at least. All right, so I'm going to be like naive and optimistic. You didn't have time, okay, to work on that. That's okay. We're going to play with it now. But that kind of stuff, honestly, like when I show it to you, it's going to help. But if you want, like in 2 days, once you have kind of forgotten what I said, to try again, do it. It's worth your time. That exercise, that example, is a very how to say, it's not a BS, training exercise or something like that. It's not trivial. It's actually at a good level for the class, meaning that, for example, if I ask, without showing you how to do it, if I ask you at the end of the semester, hey, I want you to write a program that's called a tokenizer, and I'm going to tell you what I want the code to do, but I never showed you a tokenizer before. That would be a hard final for this class. For like a first programming class, yeah. So this is good for you to set your expectation, to set your sight on, okay? If you understand that, if you're comfortable with that, okay, you're like already halfway there for the final exam, okay? So this is a code from the slide. So what we're going to do, we're going to take a look together and I'm going to try to explain to you what it does. So this one is a version that is in correct order, okay? So if you type something like, hello there, people, okay, without a space at the end, it's going to identify and break down things word by word. But the trick for this code is that if I start typing something like hello, 3 spaces, there, 2 spaces, good, 1 space, people, space. Well, it's ignoring all those extra spaces, okay? Including if I look at the beginning, space, hello, there, people, yeah. I'm having a stroke, sorry. I should not joke about that anymore, but so hello there, people. Yeah, it's able to actually, kind of ignore the spaces in between. So we know how to ignore the spaces at the start and the spaces at the end. It's really super easy. You call the trim method. That's what it does. You give it a string, you say trim that string, it snips the 2 ends that contains only spaces, and gives you the string in the middle. But what about like when we have multiple spaces here? So this is where the code gets a little bit more complicated. So I don't expect you to write this from scratch, without any form of guidance, but we are going to analyze it together because this is a very good application of everything we covered in that second part of the lecture. And I'm not going to update that now. I learned that years ago. All right, let's take a look at the code. So beginning, we need a scanner. Okay, so far so good. We need a string. We're going to call it str. It's initialized to empty string, and I'm going to have also a string named word that's initialized to empty string. So str is going to be my whole message, whatever the user typed. word is going to be a string that I'm going to use to refer to the first word. And then next iteration is going to refer to the second word, and then the third word. So I'm going to constantly update it, okay? I tell the user, type something. I read next line. So everything that was typed until enter was pressed, put that into str. And then I have a variable end here. You're going to see what I use it for, but pretty much end is going to be an index to tell me, where my first word is ending. So I start very conservatively. I say, okay, you know what? Maybe the string is empty. So the n is going to be index 0. And then I'm going to see if I can do better than that. Then we have a loop. So it's an interesting kind of loop, and we're going to talk more about loop at the end of the session. It's a while true loop. I don't remember if we used infinite loop on purpose. I know that some of you add infinite loops without meaning to have infinite loop. I've been doing that to live coding and stuff like that. So generally, an infinite loop is a bad sign. I forgot something. I forgot to increment my counter, or it's not incremented properly, etc. Here, I did it on purpose. The condition is always true. So that loop, every time it evaluates, should I go again? It finds a true and it says, sure, let's go again. So this loop is never going to end. But I use here a keyword that we're going to, so I anticipate a little bit on the next lecture here. I use a keyword called break that's going to allow me to say at some point, thank you for the dramatic effect. This was perfect timing. So it allows us to say at some point, hey, I want to break out of the loop. That's what it means. If you are in a loop and you execute break, bam, you get out of the loop. Okay. So you bypass the condition, you immediately get out of the loop. So what I'm saying here is I'm saying if the length of my string that I just read from the user is 0, then break. Before that, I don't want to count like spaces, etc. So I trim the string. So any space at the beginning, any space at the end are gone. Only thing that's going to be left is nothing, okay? If the string pretty much had only spaces in it, or if the string had some sort of message in it, then it's only that message that's going to be left, okay? So now I'm measuring the length of that thing. And if really it's 0, I don't have anything else to process. I'm not going to find another word in that stuff. It's empty. So break out of the loop. Here, end equal str.index of space. So index of, remember, from beginning to end of the string, I don't specify a second parameter, so I start at index 0. So starting at index 0 in my string, where is the first space? But remember that I trimmed the string. So there's not going to be any space at the beginning. It's going to start by a letter. If there was no letter either, I would have broke out of the loop already. So here, where is my first space? So let's say that the string is Jim something, Jim Smith, okay, with a space in between. That's going to tell me where the space is. Okay. If end equal -1, what's going on here? Well, the thing about index of is that you're not going to always find what you're looking for, whether it's a character or a string. So what we didn't discuss yet, it was on the side, but I didn't make a big deal out of it, is what happens when index of is called to look for a character and it doesn't find it? Well, it's supposed to give you an index. An index is a number between 0 and the length of the string -1. So the convention is if I don't find what I'm looking for, I'm going to return the value -1 because -1 cannot be misinterpreted as being an index. In Java, we don't have negative indexes. Those of you who did Python, yes, Python has negative index and they mean something. In Java, it's not acceptable. So if the value returned by index of is -1, then I know that I didn't find a space. So what does that mean? And this is where it's also interesting for the way you think as a programmer, right? Like you have to put everything together. So you know that you removed any heading spaces and trailing spaces. You know that this didn't trigger, so you have at least one character in the bloody string. Now you say, I want to find the next spaces. So I want to find the space that comes after the first word. I don't know how long that word is, but I'm going to look for the space after it. Well, if I don't find one, that means what? That means that right now, what I have left in my string is a bunch of letters and then end of the string. So I can infer all of that because I've ruled out this, I've ruled out this, I've ruled out this, and now I find myself with -1 here. So I'm going to say my word, my next word, it's right here. It's a whole string. It's a series of characters up to the end of the string. That's the last word in that string. So I make my variable word refer to the same string than str. And then I tell str, go take a break. We don't have anything more to look at. I'm pointing to the last word. So next time we iterate, I want you to consider that what's left to analyze is empty string. That's what's going to allow us to get out of our loop. Because when I go back here, I'm going to trim an empty string, which does nothing. And then I'm going to check if the length is 0. The length of an empty string is 0. And that's going to get me out of the loop. So that's what I do if I didn't find a space. If I found a space, well, that means that there's a bunch of characters, a space, and maybe over characters, right? Not maybe, surely over characters, because if there was nothing after the space, that space would have been trimmed, right? So I know that there's more words to come. So I say word equal str.substring 0 end. So that's a string starting index 0 up to end, which is the index of the first space that I encounter. I'm going to take all of that. But remember, I don't take the inclusive end index. So that means that the space is not going to be sticking at the end of my word. So I extract the first word. I photocopy the first word. And I have a new string, which the variable word is referring to. And then, and what about str? So str, now what I would like to say is, the next time I iterate, I would like str to not refer to the same string, because I'm processing the first word. I want it to refer to a copy of the string that contains whatever is left. Substring end, where the space is, and then up to the end of the string. So I'm going to start right here where the space is. So the rest of the string is space, blah, 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 end of string. That space is in the way. Well, don't worry, we're going to trim it here, okay? So that's the choice. Was it the last word? Yes, handle it one way. Wasn't it the last word? No? Okay, so make a copy of the current word that we're looking at, make a copy of whatever is left in the string, and now we change the value of word and string. I can display whatever is in word, no matter which path I took, and then I reach the end of the loop, and I'm going to say, okay, next. So what's left? I look at str, I trim it, I figure out if this is 0. If it's 0, I'm done, there's nothing left. Otherwise, I look for the next space. Rinse and repeat, okay? So again, very good practice for you. Like tokenizer is a classic. It's a classic old school assignment for introduction to programming, okay? Maybe some could say, maybe before we realized how heavy it was actually on the student and we started like trying different things, okay? But that was typically in an introduction book, you would find a tokenizer. I still use it in my course, but I don't use it to grade you. I use it to show you a very clever program so that you can start setting your expectation up about what should I be able to write when I take my second programming class, okay? Can I figure out the logic here? Can I understand the code? If you can, then you're already halfway there. All right, and that's pretty much it for the story of strings as far as this course is concerned. So now what we're going to do, so I need to transition to the next slide deck. That would be probably a good idea. There we go. So we have a little bit, well, we have time left. So we have time left. We are going to get started with the next module, which is going to be module 7. So here's the deal with where we stand in the content of the course, okay? Module 4, I don't know, I cannot put a percentage on it, but some of it was new, like typecasting was definitely new, the new data type. So there was a lot of new stuff, but it was really about building block 0, building block 1, right? Declare and initialize a variable, assign a new value to a variable. So we still covered something that we already saw before, but went more in depth. This one should have felt a little easier. The only thing that was really new there was Boolean algebra, Boolean expression, right? So the logical and, logical or, etc. If you never saw it before, then that was new. But the conditional statement, it all boils down to the good old if else. Even the switch can be replaced by an if else. The ternary conditional operator can be completely ignored and replaced by an if else. So kind of like at least halfway non-terrain. Useful method, well, that one was a lot of new stuff, okay, especially the string. That's actually, it should feel new. And then iterative statements revisited. That's going to feel like the conditional statement revisited. We know already how to write loops. We use a while keyword, while a condition, curly braces, etc. So it's not that complicated. We've been already going over everything that you can do from a design perspective with loops. So now we are going to fill in the blank and just add a little bit more syntax. Just like we added the switch statement as another way to do a conditional, well, we are going to see different ways to do loop. So reading assignment is chapter 5 for this module, actually entitled loops, not optional. You can see that the stuff in green is what we already covered. And this is actually, I would argue, this is the hard part, how to write programs that use loop. And then what we have left that we are going to focus on in the lecture in red is writing a loop using the do while statement. Instead of the while statement, there is a do while statement. Then there is a for statement, okay? And what are the similarities and difference between while, do while, and for? When do I use which one? Why does it matter? So that, in comparison to being able to do this, is relatively easy. Okay, so we're going to talk a lot about syntax, and then there are some little detail here that I leave for the reading assignment. In terms of learning activities, we are going to have a full house again. So PE already, well, they're going to be in the next slide. PQ is already released. DQ is already set for a due date. GE, well, you know what's going on with CodingBat. By the way, I still haven't heard back from CodingBat, so I'm starting to be cautiously pessimistic. So keep saving those code that you run in CodingBat. You can still use CodingBat and run your code and get all green, right? But then when you get all green, just save it in a text file. And probably very soon, if I don't hear back, I'm going to ask you, okay, send us the text files we're going to grade by hand, okay? But it's already listed in the module, and we are going to have an IE, okay? So I know announcing an IE before we are even done with the current one is not really diplomatic, or I don't know what word to use here, but we have an IE at the end of this week, and then we're going to have an IE coming up, and I'm going to try to space them by at least 1 week, so every other week, okay? Here are the P's, here are the G's, so you're used to that by now, okay? And here are 2 slides or 3, I don't remember, on stuff we already know. This is a while loop. Shocking surprise. So counter initialization, condition, the body of the loop, and then we have to increment or decrement the counter, okay, by 1 or more. And then this is the end of the loop. So yeah, that's what we have been using since the beginning, okay? We've seen how to do sentinel control loop. We're going to talk a lot about sentinel control loop because sentinel control loops can be awkward sometimes. Example, case in point. Declare my scanner, set value to -1. So value is what I'm going to read from the user. It's an int. And I set it to -1. Well, that's mysterious. That's really mysterious. What does it mean? Why -1? Why not -2? I would have put a 0 there, but anyway. So something here that's potentially a source of bug or misunderstanding. Then tells the user, keep entering positive integer values, enter 0 to quit. Oh, okay, so 0 has a special meaning. So that's probably why value is -1. Oh, yep, there you go. While value is different than 0. So if I would have put a 0 here, that while was false, I never even iterated 1 time. So I had to play sneaky here so that this first condition passes, and then I read my actual first value from the user. And then I say if value is different than 0, so if it's not the 0, that means get out, then system.out.println, your value is ternary conditional operator here. Just, why not? Because if I write if else, I'm going to look like a noob, so I'm trying to make it, like show off here. Value modulo 2 equal 0, question mark, that's a condition. If that's true, I put even, else I put odd, that I concatenate to your value is. So it's going to display, I enter a value, it's going to tell me that value is even or that value is odd. Awesome. So nothing there that we haven't seen before, okay? But we are going to use that as a base example so that I can try to demonstrate to you that over syntaxes might make actually that kind of work a little easier to write and to read than using good old, while. But so that we are 100% clear, this program works. This program is your objective. So if you set expectation again, this is what you need to be able to write by yourself as a final exam. Now, whether some of you are going to go and use a for loop or do while loop, because you're comfortable already, perfect. But for the others, if you're comfortable with this, you can stick with this when you write code. So let's talk about the for loop. So the syntax, I want to represent it as a block diagram, is the keyword for. So here's a new keyword in Java. It's been a while. A pair of parentheses, just like the while. Okay, always a parenthesis after the loop. Open curly brace, close curly brace. So yeah, that's just like the while statement. And then there are three parts here separated by semicolon. So that's different. So it's not a condition between the parentheses. It's no longer just a condition. It's statements that are going to be executed before the loop starts. And that's what a lot of students find weird, to say like you start the loop here and you tell me of stuff that needs to happen before the loop. Well, that's just the syntax. And that's the syntax used by many languages, including C, right? So get used to it. Pre-loop statements here, this gets executed one time before the loop starts, only one time. This is my continuation condition. So this is a condition you would find in a while loop. This is end of iteration statement. So that's, you could think, well, this is going to be what happens before the loop. Then my for is using this condition just like a while, and this is going to be what happens after the loop. No, that would be too easy. This is what happens when we reach the end of each iteration. So you specify here if you want to increment, decrement a counter, you would put it with that syntax up front, up there. And this, the only thing that's left is whatever you want to repeat. So here's an example of code. I want to display a number n followed by dot, dot, dot. So I want to display a number, dot, 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 a number, dot, 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 okay? My int n equals 0 is here. So I still declare the variable that I'm going to use as a counter in my loop. For n equals 5, so this is a pre-loop statement. So that's going to be executed exactly one time before I enter the loop. So at the beginning, n is set to 5. And then my condition is n greater than 0. So I evaluate my condition. 5 is greater than 0, true. Where do I go next? Here? Well, hell no, that would be too easy, right? I go here. I execute everything that's between the curly braces. So I display 5 dot, dot, dot. And then I reach the end of my loop. When I reach the end of my loop, I trigger that part. N minus minus. So n goes from 5 to 4. And we go again. Do I execute this again? No, that was just one time before the loop really starts. Now I'm spinning. So I test again like a while. 4 greater than 0, true. Go here. Execute everything in the curly brace. When you hit the closing curly brace, decrement n, you are at 3. 3 greater than 0, you get the ID. Okay? So is it disturbing that when I read this, I'm doing it one time, then I'm going to test this, do that, come back here, test again, ask it that one, do that. It's kind of weird the first time, but pay attention to it. That's the weird thing about the for loop syntax. Why do people use the for loop syntax if it's so weird? Because the one subjective advantage of the for loop syntax is that when I do a counter control loop like this one, I can look at just the first line, the for line, and it tells me everything there is to know about the iteration of the loop. So for counter control loops, this is awesome. This is where the counter starts. I'm going to keep going while it's greater than 0. And at the end of every iteration, I decrement by 1. Everything is right here up front. I can just read that and I know exactly how many times the loop is going to spin. That's all there is to it, okay? People add features into language because they want convenience. Why do some of those features do not feel convenient to a novice? Because the people that add the feature are people that have been programming in the language for a long time, and they have developed different needs that we have when we just learn the language for the first time, okay? But this is a very common pattern followed by many programming languages, so it's worth getting used to it. So that means that this block syntax for the for is exactly, asterisk, is exactly, almost, legal disclaimer, this is maybe not exactly, equivalent to a while. So in a few slides, I'm going to show you the one counter example where I can write a for loop and it's not going to be equivalent to the while. But for like everything else, like again, in decades of teaching that, I have never encountered that situation where the two are not exactly synonymous of one another. Okay, but I'll make sure I cover that for you. So you got your preloop statements before the while. Your continuation condition just go in the while. Your block of statement goes here, and this goes right here. So now you see it laid out like that. You see exactly the meaning, the semantic of the for loop is just another way to write a while loop, right? So it's just syntactical sugar. The while loop that corresponds to this one would be this. I can translate just using the mapping from one block diagram to the other. So if I try to do controlled loop like this. So this is my while counter control loop. This is the for syntax. Okay. So first thing I already told you is that everything about the counter control aspect is here. So that means what? That means that between the curly brace, I only have to worry about what do I want to do at each iteration. I don't worry about the logistics of decrementing or incrementing the counter. It's taken care of here. So granted, this is a minor thing, maybe for some, but that's one of the attraction of the syntax. The second thing is that those preloop statement here, they can actually contain variable declaration. But now I need to put a warning. If you write here for int n equal 5, remember how I told you that it's pretty much like the preloop statement. It's pretty much like if they were before the while loop. Well, not exactly. So I need to asterisk, footnote, font size 5. What happens here? You declare a variable n, you initialize it to 5. So before you start the loop, you declare that variable. But does that mean that the variable is going to be usable anywhere, before the loop, after the loop? No. If you declare anything here during the first part of the syntax of the for loop, that variable or those variable, I'm going to show you, you can declare multiple variable. Those variable here exist only between that curly brace and that curly brace. They exist only inside the loop. So if I try to display n here, compiler fails. If I try to display n here, compiler fails. N doesn't exist outside the loop. So remember what I told you about methods? Each method is its own little word and it has all of its variable isolated from the variable from the main, from the variable from another method. Well, yeah, that's the fundamental idea of variable scope. When I declare a variable, where can I use it in my code? Where does it come into existence? Where can I start assigning value, etc.? So we have been doing it easy until now. We declare the variable at the beginning of the main, and then we use them in the remaining, okay? If we have multiple methods, we declare our variable at the beginning of the method, we use them only in that method. Well, here's one more level for you. The notion of scope in the Java programming language, like the C programming language and a few other, the notion of scope is tied actually not necessarily just to methods, but it's tied to those pair of curly braces, which are the blocks. Building block 0, you can have like a sequence of statements. They can be in a block. You can put a block inside a block. Well, every time you put a block inside of a block, it's like you define a new scope, a new space for having variables that are going to be isolated from others. So here, that int n equal 5 is scoped to the body of the for loop. That's it. Not usable before, not usable after. I cannot change it from outside the loop. It exists only in the loop. So little by little, yeah, it's little syntactical details. They don't look like much, but little by little, they allow me also to kind of like nudge into your mind ideas that connect to what we have seen before, but that we didn't cover 100%. So we're kind of filling the blanks as we go like that. So, of course, we need more syntax. Come on. There's another thing that you can do commonly with for loops is you can have multiple statements that you want automatically executed when you reach the end of the loop. And you can have multiple statements that you want executed before you start the loop. So the statement that come before we start the loop, it's always either setting a value to a variable, like I equals 0, or declaring and initializing a variable, like for example, int I equals 0. So those little counter variables that we have been using in loops, Most of the time, except if I need to use them outside the loop, I just declare them here. Int I equals 0. And if I have another for loop here, I can still reuse int I equals 0 because the two I have nothing to do with one another. They are in different scopes. Okay. So int I equals 0, and then I use a comma. Oh, by the way, I want another variable, j equals 0, and comma, x equals 42, and comma, z equals 99, and I can go on and go on and go on. Okay. The only thing is, all those variables are going to be int. I can declare only one type of variable like that inside a for loop. So they are all going to be int I, int j, or they are all going to be double, or they are all going to be char or boolean. Pick one, but all the variables that you separate by comma are going to be of that data type. Why is that? Well, there's no good reason. We could have made it where we can declare as many variables as we want of as many data type. It's just that the common use case, the reason for which people wanted that syntax is mostly, I'm guessing, to declare those loop indexes. You know, those little counter variables that are int. So they didn't force us to use only int. Thanks for that. But they said pretty much, okay, you know what? You're not going to declare 5 different variables or 5 different data types. Just get me your counters here, your counter variable, and you'll be gone. So you want them int, you got it. You want them as double, you got it. But pick one. Okay, that's my take on this. Yeah.
J is already a variable outside of what we're having.
So that's interesting. So what happens when you have two methods, like the main and another method, that use a variable index? They should clash, right? But they don't clash because they are in different scope. Same thing here. Like if I have for int I equals 0 here, and then if later on I do a for int I equals 5, those two variables have nothing to do. Same thing if there was an int I before or after the for loop, right? So you really look at your code with that perspective that is, where are my blocks? And the blocks that we started with, building block 0, right? They are that important. They are going to not only structure your code, like this is a block that corresponds to the first part of the if, this is a block that corresponds to the else. Yeah, they are going to be used with if, else, and while and stuff like that. But they are going to also define the visibility, the usability of all the variables that you declare. So that's a good question also. So we are going to talk more about scope again next module when we do method, when we revisit method. Okay, there's a lot more stuff to say. Yeah.
Can you do it without having like all 3 sections, so you can only use like 1 or 2?
Yes, awesome. So yeah, good question too. You can. I'm not saying this is necessarily a good thing, but yeah, you can play with the syntax to that level. So I'm going to show you some examples of that. That's going to come like right next after that side or in 2 sides maximum. Okay. So we are heading already in that direction. Now, what I want to show you is things that you can do, but it's not because you can do it that you shouldn't necessarily do it. But you need to be able to read that, because maybe the programmer that is working the next cubicle next to you is going to write this kind of code. And since you supposedly know Java, you need to be ready for this, right? That's pretty much the idea. But when you write code, you don't have to do any of that stuff that I'm showing you right now. Okay. For int I equal 1. Okay, cool. I have a variable I that I use only in the body of my loop my for loop. It initializes to 1. I lesser than 100. Okay, that's my while condition. While I is lesser than 100, keep iterating the body of the loop. When I reach the end of the body of the loop, system.out.println I++. So I display the current value of I, then I increment it. Where is the body of my loop? Remember that bug that we talked about with if else? Well, it applies to while too, and it applies to for, and it will apply to do what, etc. If I put a semicolon here, the rule is if I don't open a curly brace, that means that I don't have a block with several statements that's going to be the body of my loop. So only one statement is going to be used. So whatever statement you write here. If you put a semicolon, you wrote a statement. Your statement is nothing, semicolon, end of nothing. That's it. So what I repeat in my loop is constantly do nothing, do nothing, do nothing, do nothing. That would be a good candidate for an infinite loop. Because if I never do anything, you know, when am I going to get to the point where I reaches 100? Well, let's look at the side effects here that are implied. This part here, it's just not incrementing I. So I take care of incrementing I at the end of every iteration. Every time I'm done doing nothing for that iteration, I go here and I increment I. But I do more than that. I system.app printed an I++. So I display the current value of I, and then I increment. Nobody ever said that I could not have a method call here in that third part of the for. So a little too early, okay? Like, but when I say nobody said, then bam, go for it. Just kidding, sorry. I have a weird sense of humor. So anyway, system.out.println, I'm going to display something, right? And I'm going, no, seriously, don't worry about it. Don't hold it. And I'm going to display something and I'm going to increment. So yes, stuff is going to happen. What's the advantage here? I have a one-liner. I have a one-line piece of code that implements a loop. Yeah, so, I mean, it's kind of fun. I'm not going to lie. I like doing that kind of stuff, but I wouldn't do it if I work with other people on a project. Just because that one is not too bad, okay? But it's just like, why? Why do you want to write it in a way that is not, 100% clear and easy to understand? But anyway, that's a little subjective. I'll give you that. And then we come to your question, which is, so we have three sections in the for syntax. Good. So do we have to use them? No, not even one of them. Like if you write something like for nothing, semicolon, nothing, semicolon, nothing, that means you don't want to initialize any variable before the loop starts. Well, yeah, that's an option. You can skip that if you want. You don't want to increment or decrement any variable or do anything guaranteed at the end of every iteration. Probably I need to do something, but if I want to do it in the body of the loop, I have a choice. So I can skip that one too. And then you don't have to have a condition. And this is where it goes like, okay, what kind of drugs are you doing? If you don't have a condition, it's like if you had true. So when I convert that for loop into a while loop, what I wrote here is while true, do something, whatever is here, cut and paste it there. That's it. Is there a point to that syntax? Well, it's just what it is. Okay. And again, it's inherited. So part of it is probably legacy with other older languages. Okay. Like the C language that you're going to study. But yeah, it's how it's interpreted. So for the PQs, the GQs, you need to be aware of those things. If you see some code like that, you need to be able to understand it. If you're not comfortable writing this, I don't blame you. Okay. That's perfectly fine with me. You don't need it to get full point as the final exam. Okay. So we are back to this example where, why are we back to that example? We are back to that example of Sentinel control where we had this while loop. We are trying to detect if value is different than zero. So everything is still the same. And if I wanted to rewrite that as a for loop, well, I would rewrite it like this. Again, what's the benefit? As at best arguable, okay? But now we're going to see some other example where there is actually more value. So this is like the baseline. This is a dumbest example where, we rewrite the while loop as a for loop, but really, we don't have any business doing that. So hopefully I'm going to be able to show you some better reasons to switch to a for loop. But before we do that, we're not done being weird. So before we do that, I want to show you everything you can do with that syntax, okay? We talked about one-liners. So this program is 4 lines, but that's a one-liner. What is this doing? So I have sum equals 0, and I display the value in sum after my loop. This is a loop. What does it do? Yeah, yeah. And then it adds them up together in sum. Yeah, perfect. So that's the stuff we have been doing, right? You guys are probably sick of loops that read numbers from the user and add them up, and blah blah blah. So why did it cause you to pause a little bit and squint your eyes and stuff like that? Some of you, because it's not meant to be easily readable. So it's just what the syntax allows us to write in Java. Again, it's not because we can write it like that and we should, and it shows, it uses, it abuses even, one could say, all the possibility of the for syntax to write the code in as condensed a manner as possible. Does it make the code run faster? No, no. Your code is compiled. Okay, the compiler optimizes the hell out of your code before to generate the bytecode. So chances are that no matter how hard you try to optimize that line like that, just trying to shove everything in one line is not going to change anything with respect to what kind of bytecode is generated at the end. It's just, call it showing off, call it like demonstrating that you really understand the syntax of the language. Everything is crammed in a for statement. So where are my three parts? For, this is the first part here, int value equals 0. The second part, the condition, whoa, this is my condition. So that looks okay, different than 0. So I'm testing if something is different than 0. So while something is different than 0, I keep looping. And at the end of every iteration, sum plus equal value. All right, so I start with value equals 0. So that has to be my loop counter or something, I don't know. And I add value to sum at every iteration because there's nothing in the body of my loop. So that's the whole thing that's going to be done. And every time I check my condition, what do? I create a new scanner object. And this is between parentheses. Hold on. Generally, I do scanner s equal new scanner system.in. So generally, I create a scanner object and I assign its reference to the variable s. Here, I create the scanner object. This returns a value which is a reference to the scanner object, but I don't store it anywhere. I just use it and do a dot next int. So I call next int on the scanner that was just created on the fly. Next int causes me to read from the input buffer, looking for an int value. And then that expression here, new scanner system.in.nextInt, returns the value that the user typed. What do I do with it? I put it in the variable value. That's an assignment. Assignments are both expression and statements. So this is a statement part. I assign something that value contain, whatever the user type, and the expression part means that all of this now is going to be equal to the value I just assigned. So if the user typed 23, now I'm comparing is 23 different than 0? While 23 different than 0 enters the loop. So if I type anything but 0, I'm going to say this is true. I'm going to execute the body of the loop. Oops, there's nothing. Then I'm going to execute the statements that I want to execute at the end of every iteration, sum plus equal whatever they type, 23. And then I go back to re-evaluating my condition. But every time I evaluate my condition, I'm going to assign a value to the variable value. And I'm going to create a scanner object on the fly just to read it. It's like disposable scanners, right? Create a scanner, read a value, good, dirty, throw it away, okay? So on and so forth. It's wasteful. It's wasteful, but again, I'm trying to stretch as much as I can so that you guys are forewarned about what can be written in Java. Because you never know what style the programmers you work with or the code that you are trying to reuse is using. So you need to be able to read this, okay? But obviously, when you write code, you don't have to write it as obfuscated as this. Why is sum outside the loop? Because I tried very hard to make it as short as I could, of course, to make it as ugly as possible. Why didn't I put sum here? Like for int value equals 0, comma, sum equals 0. Any idea? Yeah? Yes, awesome. Because I need it here. So when I display system.out.println sum equals sum, I declare the variable sum outside of the loop. It has 0. I go through the loop. I refer to it, during the loop, I change its value. Then I have the final value here. If I declare for int value equals 0, comma, sum equals 0, that value here doesn't exist anymore after the loop. So my sum would not exist. And that would defeat the whole purpose. Now I would have a piece of code that is not only hard to read, but that is also buggy. Okay, double achievement there. All right. Last thing we're going to cover to finish today, we are going to cover the next syntax, which is also the last loop syntax in Java, which is our do-while syntax. So while syntax, that's what we started with. For syntax, we just covered that. Do-while syntax. So how does it work? So we have a while loop here, int n equal 5, so that's my counter. So this is going to be another one of those counter control loop that goes 5, 4, 3, 2, 1 on the screen. Okay, so int n equal 5, while n greater than 0, display n dot dot dot, decrement n, etc. So we know how we could remap that to a for loop if we wanted. Well, let's use it. Let's use instead the new syntax, the do while loop. So how does the do while loop work? Keyword do, new keyword, open curly brace, the body of the loop, kind of like the same thing than here, right? And then close curly brace, and the while condition is after the loop, still use parentheses and everything, and then a semicolon here. That semicolon is not a bug, or it should not be a source of bug, okay? That doesn't mean an empty loop. That means actually end of the do while loop. And now you see why some people write a while loop and put a semicolon here. Because while you are learning, if you learn all the types of loop at the beginning when you don't know exactly what you're doing, then it's kind of like a reflex to put semicolon here. You end up putting semicolon there. And when you don't use a curly brace, you get a bug. Okay. So for us, that should not have happened as often because we started writing the stuff correctly with a while loop. And now we are introducing only now alternative syntax. So what's the point? So yes, that semicolon is mandatory. What's the point? If I execute the stuff on the left, I get 5, 4, 3, 2, 1. Hooray. If I execute the stuff on the right, 5, 4, 3, 2, 1, exact same thing. So great, I have the third way to write exactly the same thing, okay? So watch out. When you write something with a while syntax, I told you the vast majority of the time, what you write with a while syntax, I can just transform it, into a for, and the for and the while are going to have exactly the same meaning. There's one exception to that. I'll cover it before we end this module, okay? But that's it. And you have really to try hard to make it so that that exception happens, okay? Here, it just sounds like this is exactly the same thing. That I'm going to tell you, yes, the while loop, you can rewrite it as a do while, and it's going to be exactly the same. No, this is actually the exception. This is a case where I reuse the parts. My condition is here, my body is here, initialization. I reuse the part to rewrite this as a do while, and it works exactly the same way. But that's not the case. Okay, most of the time it's not the case. So take a look at this code here. I mean, actually, both codes. Do you see a way for me to change exactly one character in the code so that when I change that character here and here, then this loop doesn't behave the same way as this loop? So you can erase a character, you can replace a character by another character, stuff like that. Yeah? That one here? Yeah. So that 5 there, that 5 made it so the loops are behaving exactly the same way. So what if I have another version of the code where I modified in both code, n equal 5 is replaced by n equals 0. So technically, yeah, I only change 5 to 0. Well, this is where the difference between those two types of loop get obvious, okay? What's going to happen here? N equals 0, while n greater than 0. That's false. Get here. System.out.println, empty line. Go to the next line. That's it, nothing. What happens here? Int n equals 0, do system.out.println n 0, followed by dot dot dot, n minus minus, n is now minus 1. While n greater than 0, that's false, println. So that's the only difference. The while and the for loops, they are called test early loops. They are both considered as test early loop because we test things early in the process of looping. This is the first thing we do. We test a condition, and only if the condition is true, then we go for our first iteration, then we test again at the beginning of the second iteration, and then we go only if it's appropriate, okay, if the condition is true. This loop, actually, there's only one of them in Java. This loop has a different logic. It's a test late. So that means that I'm going to do whatever you want me to repeat, at least one time. And then I'm going to ask myself, should I continue? While n equals 0, if it's true, go for it. Again, while n equal greater than 0, should I continue? If it's false, stop. That's it. Okay. But as you are going to see in some of the examples that we have coming up, this is actually interesting, and this is actually allowing us to write code sometime in a way that is easier to read. Okay. So here's an example. I'm going to use do while. So do while I've used a lot for Sentinel control loop. Okay, that's kind of what they excel at. When I introduced the for syntax, I kind of hinted that the for was introduced because some people like to have their counter control, data all on the first line of the for. So yeah, for and counter control loop, they go like hand in hand. Well, do while generally goes very well with Sentinel controlled designs. Okay, why? Because like, for example, here I have a scanner, right? I want to, oh, again, this is like, give me numbers. I'm going to add them up. When you give me 0, I stop. Okay. So same example, nothing difficult here. But what I'm saying now is I'm going to start by anyway, tell the user to give me a number. Because really, I should not be trying to decide if I'm going to stop before I ever got a number from the user. That's what I had to do with the while, because the while was like the condition was early in the process, right? But now I have a way around this. Do this. So ask the user for a number, read that number, then add it to sum, and keep doing that while data is different than 0. So the only thing I would change here is instead of adding data to sum, I would do a if. If data is different than 0, add it to sum. But really, it doesn't matter because our Sentinel value is 0, right? But if the Sentinel value was not 0, then we would need a little bit more work here. And then display the sum is blah. So I'm going to go fast around this because this is just, like I already pretty much covered everything. So we're going to end with this. Guidelines for are good for counter control, while are generally good for Sentinel control. While are good for both actually counter control and Sentinel control. But now that we have the for loop, most people use for loops for counter control, and while can kind of get delegated to Sentinel control or general purpose loop. And do while, generally we go from while to do while when we have a Sentinel control loop that's reading something and needs to read a first value to get started. But all those loops, they have a lot of stuff in common. Okay, so all the loop can be nested with one another, can be arranged serially. That's still true. Whatever we learn with the building block, still there. Okay, we can use every loop to do Sentinel control design, counter control design, or general purpose design. It's just going to be a little bit or less awkward. Okay, all of the loops that we've seen so far, they are based on what we call a continuation condition, meaning when the condition is true, I keep looping, and that's it. And then pre-test versus post-test, well, yeah, we just introduced a syntax that is a little different. So for and while are testerly. We call that also in some textbook pre-test loops. And then the do while is a post-test. So we do something and then we figure out if we should continue type of loop. And that's it. We are going to stop here, part of which because we're like at the end of the session. But and then next time we'll start with some examples where we are going to try to make the point that some syntax are easier for some design. Thank you.